My name is Stanley Edessis, and in this lesson, we will explore how to open, navigate, and modify XML layout files, the files which act as blueprints for the design of our application. Activities present interactive content to the user, and layout files dictate the appearance of that content. Let's discover how we build and modify layout files to suit our needs. We'll start with a default Android Studio project using the empty activity template. Our Android project files belong to one of three main categories: configuration, code, and resource. Configuration files define the project structure, code files provide the logic, and resource files are pretty much everything else. To browse the Everything Else section, we navigate to the Resource Manager. Without going into too much detail, drawables represent the images we bundle with our application. Colors are defined in Android using static hexadecimal values, where each pair of characters represents red, green, and blue levels, respectively. These were set by Android Studio as our theme colors. And in IO3, we find layout files, exactly what we're shopping for. Best practices suggest we name our layout files the same way Android Studio named this one. The file name begins with activity, the type of arrangement represented by the layout, followed by main, or the Java object that relies on this layout. Main refers to main activity, the activity object that Android Studio created for us in the previous step. And we double click the file to begin editing. Okay, so there's a lot going on here. To help us focus, we'll hide the resource manager by clicking its name on the panel. This portion represents the constraint layout, a view group we briefly discussed in the previous lesson. And view groups are views that may contain and position other views. And this portion corresponds to a text view, the only child view within the constraint layout, and one that is capable of presenting text on screen. Eventually, navigating these intimidating layout files in text mode becomes second nature, but we'll switch to design mode for clarity. Design mode allows us to interact directly with a visual representation of our layout. Using these controls, we may alter parameters to see how our layout appears in different languages, themes, Android versions, and devices. For example, we may switch from the Pixel 3 to the original Pixel device, or any configuration we desire. We may also rotate the canvas to see how our layouts behave when the screen is wider than it is tall. But we'll stick to portrait mode for now. And this entire time, we've studied our layout in design mode. This toggle can switch us to blueprint mode. In blueprint mode, Android Studio draws the bounding boxes of our views and their spatial relationships to one another. Nothing more. Developers with slow machines stick to blueprint mode and switch to design mode to check their work. With those details out of the way, we can begin manipulating our layout visually. We may select any view within our layout using our mouse cursor. By clicking, we focus the editor's attention on a specific view. We control a view's appearance, position, and so much more through attributes, now revealed in Android Studio by the right-hand attributes panel. To help us understand this panel, we'll close the declared, layout, and common sections. The All Attributes section lists every attribute we can apply to our text view in alphabetical order. This includes attributes inherited from parent view objects and those that apply exclusively to text view. We find the name of each attribute in the left-hand column and its assigned value in the right. If we're ever unsure of an attribute's purpose, we may hover its name with our mouse cursor to reveal an educational tooltip. For example, the alpha value controls a view's transparency, and the value must be a number between 0 and 1. We can set that value here. We may switch to text mode to verify that Android Studio committed this change to the layout file. Each attribute in the attribute panel corresponds directly to a line of text in the XML file, as seen here. So it stands to reason that changes made to the text file will appear in the attributes panel as well. Nailed it! The majority of these attributes go unused, but they are always here for us to explore. We'll collapse them for now. In the Common section, Android Studio places the attributes we are most likely to set for the given view. We notice immediately that Android Studio provided two text attributes, one with a gear icon and one without. When we created this empty project, Android Studio set the value of the primary text attribute to Hello World, an insufferable cliche. But if we set a value for the text attribute preceded by the gear icon to something which better reflects our attitude, it brings some much needed pessimism to our layout. Attributes preceded by the gear icon only affect layouts when viewing them in Android Studio. They serve as placeholders during development, which is why our new, more pragmatic text takes precedence over the previous and far too optimistic statement we saw earlier. And we may apply any attribute as design time only by using the tools namespace. Namespace being the keyword that goes before the name of each attribute in an XML file. To use the tools namespace in our layout, we must have this line as an attribute of the first component. Our text view features common attributes beyond the characters it presents to screen, such as those that control its appearance. The text appearance attribute assigns a style to the text view, where a style is a reusable set of predefined attributes that may control color, size, and more. If we provide no style, TextView inherits one from our application's theme, and the Android Development Kit supplies this generic theme. By expanding this attribute, we discover two things: which attributes our style may provide, and among those, which of them were already set by our theme. In our case, text size and text color. These attributes help us outfit our text view to the exact specifications of our design, so the presence of these attributes makes sense under the Common Attributes section. But if we click another view, the parent constraint layout, for example, we see a different set of common attributes, those attributes common to constraint layout. Finally, we'll bring this home by closing the common section and revealing declared attributes. The declared section lists only those attributes for which our layout has assigned a value. This panel offers a one-to-one representation of the underlying XML content. And we'll play with two more attributes before we call it a day: layout width and layout height, the two attributes every view must provide. These attributes communicate a view's desired width and height, respectively, to its parent view group. We may set a specific dimension for width and height, such as 24 pixels, but far more common are two special values: wrap content and match parent. Wrap content requests the view be drawn only as wide or as tall as its content requires, a pixel value calculated at runtime by the view itself and supplied to the parent. Whereas match parent asks the parent view group to draw the child as wide or as tall as the parent itself. By providing access to these and all attributes, the Android Development Kit allows us to deliver appealing and exacting designs to our users.